Imagine you're sipping your morning coffee, browsing your favorite news site, when suddenly you're redirected to a site selling counterfeit shoes. You've just become a victim of a DNS attack. This isn't some hypothetical scenario, but a real-life situation that could occur to any of us at any given moment. It's a prime example of a DNS attack, an underlooked yet potent threat that exploits the very foundation of our internet usage, the domain name system, or DNS. When you type in a website address, it's the DNS that translates that human-friendly URL into an IP address that your computer can understand. It's an integral part of our online lives, and yet it's this very system that hackers target in a DNS attack. In our example, the attacker has manipulated the DNS entries, causing your browser to misdirect you to an entirely different website than the one you intended to visit. This type of DNS attack is known as DNS hijacking. The implications are far-reaching, from minor inconveniences like our shoe-selling detour to more alarming scenarios like phishing attempts, where attackers trick users into revealing sensitive information. But it's not just individual internet users who are at risk. For network engineers, DNS attacks pose a significant threat to the integrity and security of the networks they manage. A successful DNS attack could disrupt an entire network, impede access to crucial online services, and result in significant financial and reputational damage for businesses. It's important to note that this is just one kind of DNS attack. There's a whole spectrum of other types, each with their own tactics and impacts, such as cache poisoning, where attackers corrupt the DNS data stored in temporary caches, or distributed denial of service attacks, which overwhelm a network with traffic to cause a shutdown. This is a clear demonstration of a DNS attack, a serious threat in today's digitized world. But what exactly is a DNS attack? Let's delve deeper into the world of DNS attacks and uncover the underlying mechanics, vulnerabilities, and strategies to safeguard against them. In simple terms, a DNS attack is like a con artist tricking you into thinking you're in your favorite store when you're actually in a cheap knockoff. DNS, or domain name system, is the internet's directory. It's like a phone book that translates domain names to IP addresses, so your browser can load the correct web page. But what happens when that phone book gets tampered with? That's the essence of a DNS attack. Imagine you're trying to call a friend, but the numbers in your phone book have been switched. Instead of talking to your friend, you're speaking to a stranger. This is what DNS attacks do. They manipulate the phone book of the internet, leading you to the wrong number or website, often for malicious purposes. Now let's delve into what we call DNS vulnerabilities. These are weaknesses in the DNS system that make it possible for attackers to exploit it. This could be due to outdated software, poor network configurations, or even human error. These vulnerabilities are like leaving your house door unlocked. It's an open invitation for trouble. There are several types of DNS attacks, but we'll focus on three main ones: cache poisoning, hijacking, and DDoS attacks. Cache poisoning is like someone tampering with your GPS, causing it to guide you to a wrong location. The attacker corrupts the DNS server's cache, redirecting users to malicious websites. Next, we have DNS hijacking. It's equivalent to someone stealing your car and taking it for a joyride. Here, the attacker takes control of the DNS server, redirecting all its traffic to a website of their choice. Lastly, let's talk about DDoS attacks. Imagine a highway clogged with cars, resulting in a massive traffic jam. That's what a DDoS attack does to a DNS server. It floods the server with so much traffic that it becomes unavailable to users. These are just a few types of DNS attacks that can wreak havoc on a network. But how do these attacks actually work? Think of DNS attacks as a game of deception, where the attacker manipulates the rules to win. This statement encapsulates the mechanics of DNS attacks. Just as in a game of deception, the attacker uses tactics like cache poisoning, hijacking, and distributed denial of service, DDoS, to gain an advantage. Let's start with cache poisoning. In our game analogy, cache poisoning is like a player swapping out the game's rulebook for a fake one. In the world of DNS, this happens when an attacker feeds false information into a DNS resolver's cache, causing it to direct users to malicious sites. Next, we have hijacking. This is like a player taking over the game master's role and manipulating the game to their advantage. In a DNS hijacking attack, the attacker redirects queries to a different DNS server, often one under their control. This can lead to users being sent to fraudulent sites or having their information intercepted. Then there's the DDoS attack, which is like a player flooding the game with so many moves that it grinds to a halt. In a DNS DDoS attack, the attacker overwhelms a DNS server with traffic, causing it to slow down or crash, effectively blocking users from accessing the services they need. But just as in a game, there are ways to counter these tactics. Security best practices include regularly updating and patching DNS software to fix known vulnerabilities, implementing DNSCC to authenticate DNS data, and using firewalls to block malicious traffic. Monitoring DNS activity is another crucial aspect of defense. Tools like DNS log analyzers can help identify unusual patterns and potential threats. And when an attack does occur, having a robust incident response strategy is key. This could involve isolating affected systems, investigating the source of the attack, and implementing measures to prevent future incidents. In this game of deception, knowledge is power. Understanding these mechanisms is the first step towards protecting your network against DNS attacks. But what about emerging threats and trends? In the world of cybersecurity, staying updated is not an option. It's a necessity. As the landscape of DNS attacks evolves, so too must our defenses. Emerging threats are as varied as they are numerous, from increasingly sophisticated cache poisoning techniques to relentless DDoS onslaughts. Being proactive is the key. Network engineers should stay abreast of these new threats, keeping their knowledge fresh and their skills honed. Security best practices are our trusty allies in this ongoing battle. Regular patching, implementing DNSCC, and routine auditing are just a few of the measures we can take to safeguard our networks. But remember, monitoring is equally as critical. Effective tools that provide real-time visibility into DNS activity can be a game changer, allowing us to spot anomalies and respond swiftly to any potential threats. Remember, the best defense is a good offense. Stay informed, stay vigilant, and you'll keep your network safe from DNS attacks.